Okay, the last two examples in lesson 89 involve relationships between circles and segments. And the first thing I want to bring to your attention is this one on the top left on this white piece of paper I handed out to you. The top left here has what's called two chords. Okay, so these are chords. A chord is a segment in a circle that connects the circle without going through the circle. So it starts on one edge, goes to the other edge. It doesn't have to necessarily go through the center. Okay, these aren't diameters, they're chords. But the two chords do intersect somewhere inside the circle. That's the important thing here. If you have two intersecting chords inside a circle, the product of the pieces of one chord is equal to the product of the pieces of the other chord. That's just a basic relationship of circles and chords. So this A is this piece, B is this piece, C is this piece, and D is this piece. A times B is equal to C times D. That's always true, never false. Okay, the other three all involve secants and or tangents. A secant, it doesn't necessarily have to be a circle, it's going to be a circle right now, but a secant's any line that intersects a curve in two or more spots. So this secant, notice, intersects twice, that one intersects twice, this intersects twice. Okay, a tangent is a line that intersects a curve in exactly one spot. That intersects once, once, once. If you have two secants and the same circle, a secant and a tangent on the same circle, or two tangents on the same circle, there are relationships of the segment lengths involved. And with secants, it's always the outside piece being multiplied by the whole piece. So outside piece A times whole piece A plus B equals outside piece C times whole piece C plus D. If it's a secant and a tangent, outside piece times whole piece for the secant equals the tangent squared. If it's two tangents, their tangents are equal to each other. And we've already seen this before. We had a triangle, said that all the circle was tangent to all the sides, and they gave us this but not that, and we had to figure out what x equaled. I think like less than 20 something. Like yeah, two tangents to the same circle are equal to each other. Typically they're going to give you problems that look like these, but in case they do, two tangents are equal to each other. Example 89.5 has the two chords intersecting inside the circle relationship. And the two pieces that make up this chord are x and 10. And the two pieces that make up the other chord are 5 and 4. The relationship says the product of the two blue pieces is equal to the product of the two red pieces. If we simplify, or if we solve that, we're going to get x equals 2. Simple, straightforward. If you see the picture, you know the property, you write an equation, you solve an easy equation, you get a correct